Hey, St. Mary grade 8s, Mr. McHenry back for another math lesson with regards to Pythagorean theorem. And today we're going to talk about some special triangles. And we can identify right triangles within isosceles triangles or equilateral triangles. And then we can use Pythagorean theorem to find the height or side length of the triangle. And if we know the height of the triangles, we can find the area of the triangles. And if you recall, the area of a triangle is equal to base times height divided by 2, or half times base times height. So whichever one you like to use. I like to use the base times height divided by 2. So let's take a look at the isosceles triangle. And can we identify any right triangles within the isosceles triangle? Well, what we can do is we can drop a line in right here from one of the vertex. Okay, in an isosceles triangle, it has to be the vertex that is in between the two sides that are equal. And when we drop that line in there, we create a line of symmetry there, and we also create a right angle there. And now that we have a right angle, we can identify where the hypotenuse is, so that would be C, and we can also identify where A and B are. So I'm going to put A here and B here. So you might also note that when we drop that line in there, that we take the base of the triangle and we divide it in 2. So this side of the base is equal to this side of the base. All right. So now we have a squared plus b squared is equal to c squared, where a is equal to the height of the triangle. All right. So similarly, we can look at an equilateral triangle and identify any right triangles. And in an equilateral triangle, you can drop a line in from any of the vertexes. I'm going to drop it in from this one right here. And again, it creates a right angle here. And again, it divides the base into 2 equal parts. And as a result, we can identify where the hypotenuse is, C. And again, I'm going to label A here and B here. And again, we can write out Pythagorean's theorem, where a squared plus b squared is equal to c squared, where a is equal to the height of the triangle. Okay, so let's put this into action. So we have an example here. So in this example, we want to find the length indicated. And the length that is indicated is, and I'm just going to put it in right now, is actually h. So the length indicated we want to find for h. Okay? And we also want to find the area of the triangle. Now, when I look at this triangle, what do I see? Well, I see that it is an isosceles triangle. And I know it's an isosceles triangle because the two sides are equal from the hatch marks here. I also know that the base of the triangle is equal to 10 centimeters, and I want to find for h. Okay? Now, can I identify any right triangles? Yes, I can. I can identify a right triangle, and I'm going to put the right triangle on the right side. I'm going to create a right angle there, and therefore I am then going to use Pythagorean theorem to find h. So I'm going to identify the hypotenuse, which is opposite the right angle. So C is equal to 13 centimeters. Okay, and this is A. But I don't have a value for A. And this is, and I'm going to put B here. And I don't have a value for B, and I actually want to solve for B, because if I solve for B, I solve for H. So I need to find a value for A. And in order to find a value for A, I can take some information here that the base of the triangle is 10 centimeters, while I have half of the base. So if I take half of the base, that's 10 divided by 2. Okay, and 10 divided by 2 is equal to 5. So A is equal to 5 centimeters. So now that I know two sides of the right triangle, I can use Pythagorean theorem to find the third side, that being B. And when I solve for B, I also will solve for H. So I write down Pythagorean theorem: a squared plus b squared is equal to c squared. And I substitute in any known values. Well, I know a is equal to 5, so 5 squared plus b squared is equal to, and I know c is 13 squared. So this is going to be 25 plus b squared is equal to 169. I want to isolate for b squared. So to isolate for b squared, I need to get rid of this 25. So I subtract 25 on the left side, but in order to keep the equation balanced, I have to subtract 25 on the right side. This cancels out. I'm left with b squared is equal to 144. I don't want to know what b squared is equal to. I want to know what b is equal to. So in order to find out what b is equal to, I need to take the square root of b squared. So unsquare the square. But in order to keep the equation balanced, I also need to take the square root of 144. So b is equal to 12. Okay, so therefore b is equal to 12, therefore h is equal to 12 centimeters. Okay, now, so that was the first part. The second part is I need to find the area of the triangle. So the area of the triangle, so area of the triangle is equal to base times height divided by 2. Okay, do I know the base of the triangle? Yes, I know the base of the triangle. The base of the triangle is equal to 10 centimeters, the full base. So I can substitute in there. Times the height. Do I know the height of the triangle? Yes, I just solved for the height of the triangle, equals 12 divided by 2. okay, which is equal to 120 divided by 2, which is equal to 60 centimeters squared. So therefore, the area of the triangle is equal to 60 centimeters squared. Okay, so that is using Pythagorean theorem with isosceles and equilateral triangles to find their side lengths and their areas. Please check D2L for the practice questions so that you can feel confident about using Pythagorean theorem with isosceles and equilateral triangles.